All right, so this is 2.3. So section 2.3. What we're talking about is the precise definition of a limit. Precise definition of a limit. And what we know is our precise definition basically says that if I say the limit as x approaches c of f of x is equal to L, what that means is if x gets really close to c, that's what that thing means. As x gets really close to c, that's what that means. Then, so really we usually use a double arrow, then f of x is going to get really close to L, right? Then f of x is going to get really close to L. So what this epsilon and delta really mean, this epsilon here and this delta here, mean really, really small numbers, right? As this gets really, really small, this is going to get really, really small, right? But they're not technically going to be the same number, right? But they will be arbitrarily small in their own rights. Actually, what's kind of interesting is that this thing is related to this thing, that actually, that really delta and epsilons are functions of each other. And when you ask me to prove it, that's what we'll eventually prove. We have a proof question on there. 37. Yep, we have one. 37 asks us to prove it. Okay, so number 5. Number 5 is it gives us an interval here. So I don't know if you guys can read that. That's not too bad. So what number 5 says is it gives us an interval from a to b, and it gives us a c value in the middle, and it asks us to find delta. So what we know is delta is going to be the smallest part of that interval. So remember, when we're looking at a function, our function is going to look something like this, right? Like I'm just going to make a line for lack of a better function. So there's a function, right? And I know that this thing is going to be centered at c, and it's going to spit out L. So what we're looking for is we're going to have some open interval around c. Does that make sense? So let's call this one A and let's call this one B. Well, we know that delta is going to be the smallest one of these. Is that clear? So 1 through 6 just says, hey, let's not worry about the y-axis. What if I just give you an open interval? Can you guys find that smallest distance? So well, what we do is you take the absolute value of x minus c, and that's going to be equal to our delta, right? Where you're going to plug A in first and see what happens. And we're going to try it again. We're going to do x minus c is equal to delta. Then we're going to plug the b value in, and we're going to figure out what one's the smallest one, okay? So in this case, it says a is equal to 4 over 9, it says b is equal to 4 over 7, and it says c is equal to a half. So what I know is I have an interval that this is 4 over 9, c is a half, which is, I don't know where it is with respect to it. And this is going to be b is 4 over 7. Right now it shows that like 1/2 is directly in the middle just because of my picture, but that's not necessarily true, right? I just don't really have any idea what exactly decimals 4 over 9 and 4 over 7 are, okay? I work with them all the time, but I don't know the decimal equivalents off their head. So what I'm going to do is I'm going to find this distance here, I'm going to find this distance here, and I'm going to figure out what one's smaller. So what I know is the distance, again, is going to be, I'm going to take the absolute value of 4 over 9 minus 1/2 and figure out what that is. Remember, this is just x minus c, right? Where this is your x value, and this is your c value. So these really are your x values, and this is your c value, essentially, where x is a and x is b. And then I'm also going to check the other one, the absolute value of 4 over 7 minus 1/2, and see what that is. Whatever one's smaller is what I'm going to use. Okay, so in order to subtract fractions, you have to have common denominators. So top and bottom by 2. So 4 times 2 is 8, 9 times 2 is 18. And then top and bottom of this one by 9, so 9 over 18. So this is equal to the absolute value of negative 1 over 18, so this is 1 over 18. So that's what that one is. Now this one, common denominators, top and bottom by 2, so 14. Top and bottom of this one by 7. So what I get is, this is going to be the absolute value of 1 over 14, so this is 1 over 14. So delta is either equal to this one, or delta is equal to this one. What one's smaller? Come on, you can't see it, I'm sorry. Yeah, what one's smaller? Yeah, because if you divide by 18, you're going to get a smaller number, right? So this is our delta, not that one. Let's take the smallest one. So what they're trying to do is they're trying to get you to build this slowly, okay? Number 9. Number 9 gives us a picture. Let me zoom in a little bit. Now all these problems, they give you a lot of extra information, but really when we're trying to find our delta, it says use the graphs to find delta. Well, is delta this the vertical error or the horizontal error? Yeah, it's horizontal. You guys agree? So really what I'm going to do is these are my two numbers, right? And then my C value's in the middle. So I'm just going to take this difference, I'm going to take this difference, and whatever one's smaller is the one that works, right? I don't really need to know anything else, but kind of to show you how this actually works. Does you guys agree L is equal to 1? That's why I have 1 right here. That's why I have 1 right here, because this is L. I know that the error is 1/4. So if you take 1 plus 1/4, you get 5/4. If you take 1 minus 1/4, you get 3/4. So that's where those numbers are coming from. They're coming from L and then the given error, right? So I already know epsilon. I need to find delta. Well, delta is going to be the smallest one of these distances here. So just kind of do the same thing. So I got 9/16 essentially is your A, and then 25/16 is your B, and your C is your 1. So really the only thing we're looking at is this horizontal axis. I have 9/16 here, I have 1 somewhere in the middle, and then I have 25/16 over here, and I'm going to figure out whatever the smallest one is. So checking it again, remember the way we check these things is you take the absolute value of x minus c, right? Where these are going to be your two different x values you're going to pick, right? And then this is your c value. I guess I can say x1, x2 because you're going to have two x values, right? Okay, so, you know, this is going to go here and the c is going to go here. So we're going to check 9/16 minus 1, figure out what that is. And I'm going to do the other one, 25/16 minus 1 in absolute value, and see what's smallest. So 9/16 minus 16/16 in absolute value is going to be negative 7/16. So this is equal to 7/16. Over here you have 25/16 minus 16/16, so you're going to get 9/16 in absolute value, so this is 9/16. So what one's smaller, 7/16 or 9/16? 7, so this is my delta. So delta is equal to 7/16. All right, we'll do 11 as well. Now for 11, again, they give you the function. The function is x squared. That's why the blue curve is x squared. They give you L, so that's why 4 is L. L is the y value. Our epsilon is 1, so 4 plus 1 is 5. 4 minus 1 is 3, so that's why we know that our error is 1. So I need to find this. I need to find the smallest of these vertical errors. I mean these horizontal errors, right? So I need to take the difference of root 3 and 2, absolute value, the difference of root 5 and 2 in absolute value, and whatever one's smaller. Now the problem is I don't know what root 3 minus 2 is, so what I'm going to do is plug it in the calculator, and it's going to give me a decimal equivalent, and I'll take the smallest decimal. So again, for number 11, the only thing we're really concerned about is that horizontal axis. And I have root 3, I have 2 somewhere here, and I have root 5 over here. So I need to remember that these represent your deltas, and whatever one's smallest is going to be your delta. So I'm going to check the absolute value of x minus c and figure out what we have here. So the absolute value of root 3 minus 2 is equal to, and then I'm also going to try, or it's going to be the absolute value of root 5 minus 2. I don't know what these are, so we're going to plug them in. So second square root of 3, pull it out, minus 2. I get negative 0.2679er. So this is dot, dot, dot. So this is about 2.679. You guys agree? I'm going to do the root 5 as well. And I get 2.36. So this is the absolute value of 2.36, 1-ish. So this is about 2.361. Well, one's smaller, first or second? Second, so this is my delta. That's the one, not that one. Questions? The harder parts is trying to find these A's and B's, right? To try to find the interval, which is the next question you guys ask. So we'll find them by using the definition. So, I'm going to do a different one, okay? I just want to, let me pick one that doesn't have, the other one says mx, so let me pick one that doesn't have just variables in it, so we have an idea of what to do, and then we'll pop one with variables in it, and we'll see And we'll use the ones with numbers to make sure that our idea for the ones with variables are, so, well, they're not variables, they're constants that are unknown. So let me just pick, I don't know, I'll just pick 22. And then we'll do 27 next. So 22 says f of x is equal to x squared, L is equal to 3, C is equal to root 3, and then epsilon is equal to 0.1. So that's what they give us for 22. And what we're going to do is we're going to use the definition to find delta. And then we'll go to 27, which has m and stuff in it, so it looks a little more complicated. So what we know is our definition says that, remember, for the limit to exist, for this, as x approaches c of f of x is equal to L, or, using our letters, the limit as x approaches root 3 of x squared is equal to 3, right? So just plug in f of x, c, and L in the right locations. What this thing means is that 0 is greater than the absolute value of x minus c, which is less than delta, implies that the absolute value of f of x minus L is less than epsilon, right? That's our definition. This thing matches our definition. So just like I went from this top limit and started plugging in the correct letters and functions, I'm going to do the same thing here, right? I'm going to use this thing, I'm going to plug in the correct letters and stuff, okay? So that means 0 is less than x minus, what's c? Root 3 is less than delta, implies that, what's f of x? X squared minus L, which is 3, is less than epsilon, which is what? 0.1. So just plug in the letters in, right? Where do you start? Well, what one was given? E or delta? Epsilon or delta? So you're going to use this one. You're going to start with the one that's given, right? So I'm going to start here. The absolute value of x squared minus 3 is less than 0.1, and I'm going to solve this thing for x. When you solve this for x, it's going to give you that interval. It's going to give you essentially the a and b it said before, right? Okay, how do you solve this for x? Okay, because I can't simplify inside the absolute values. You guys agree? X squared and negative 3 are not like terms, so you're done there. So getting rid of the absolute value, how do you do that? Negative 0.1 is less than x squared minus 3, which is less than 0.1, right? I don't like that. Try that again. So negative 0.1 is less than x squared minus 3, which is less than 0.1. So when you drop the absolute values, this negative 0.1 goes over here, right? And then we solve for x. How do you solve that for x? Add 3. Okay, so this is going to be 2.9 is less than x squared, which is less than 3.1, right? Now what? Okay, I have no idea what the square root of 2.9 is. So second square root of 2.9 gives me 1.703. I'm good enough with that. 1.703 is less than x, which is less than, and then the second square root of 3.1. I get 1.761. You guys agree those are? 703. Oh, 7. You're right. 703. You're right. Nice catch. Now, there's a quick check I can do here. Remember, what's supposed to be in this interval? Remember, we have an interval here, right? This is 1.703. This is 1.761. What needs to be in the middle of it? C needs to be in the middle of it. And what's C? Okay, let's make sure. What's the square root of 3? Second square root of 3. I want to make sure that it's inside there, because if it's not, I did something wrong, right? Okay, so you can see that 1.73 is essentially C, and that does live in there, doesn't it? Okay, so we're good. So that means delta is going to be the smallest one of these, right? So I'm going to take, so now to find delta, so this is our interval, because it asks us to find the interval first. Next I have to find delta. So I'm going to take the absolute value of x minus c, and that's going to essentially be equal to our delta, right? The question is, why do I make this equal to delta when the equation up here says less than delta? we use the equality to solve the inequality, right? So kind of a little side work over here, just kind of a side note. If I ask you to go solve 3x is less than 6, well, how do you actually solve that? Yeah, you divide both sides by 3, right? It's the exact same thing as solving this. You guys agree? So when you solve this, this says x is less than 2, but when you solve this, x is equal to 2, right? So use the methods of equality to find the methods of inequality, right? X equals 3 is this dot here at 3, right? Oh, my bad, I should say 2. Is the dot at 2, but x being less than 2 is that 2, but shaded in a particular region, right? So that's why we use the equality to solve the inequality. So that's why I write this as an equality. Okay. So I know that x is going to be 1.703 minus c, which is root 3. Figure out what that is. Or it's going to be the other one, 1.761 minus root 3. And again, I just have to do decimal equivalents there. So 1.703 minus root 3. So I get, you guys agree this is negative, but when I put it in the absolute value, it's going to be positive. So absolute value of negative 0.0291, we'll say. So this is 0.0291. Or that's 1.761 minus second square root of 3. So I get 0.0289. 0.0289. What one's smaller? The left or the right? This one's smaller. That's smaller, so that's what delta is. Now, if you don't like that answer, remember what this thing came from. This was the square root of 3.1, right? That's where that came from. You guys agree? So if you want the exact answer, you could say that this is the square root of 3.1 minus the square root of 3. You guys agree? So either one would be fine with me. I would accept the decimal on the test, okay? So in this section, the decimals are fine because they give you decimals all the time. All right, 27. Questions? Cruising right along. 27. So 27 says f of x is equal to m times x. So it's a line, right, with a slope of m, y-intercept of 0. I know that m is greater than 0, they say. So they say that such that m is greater than 0. So it's a positive slope line. It says L is equal to 2m. C is equal to 2. And then the epsilon, or vertical error, is 0.03. So I'm going to go right to the definition. 0 is less than the absolute value of x minus c, which is less than delta, implies that the absolute value of f of x and L is less than epsilon, right? But this is the thing we're using. You guys agree? So plugging everything in, 0 is less than x minus c, which is what? 2. Is less than delta, implies that f of x, which is what? mx minus L, which is 2m, is less than 0.03. All right, where do we start? Yeah, we start here, right? The one that has the epsilon, right? Okay, so we're going to start here. So the absolute value of mx minus 2m is going to be less than 0.03. I have a really quick one to solve for delta. And it only works with lines. You guys agree if I factor out m, I'm going to get the absolute value of x minus 2? Yeah. And then if I divide by m, you're going to get the absolute value of x minus 2 is 0.03 over m. That's your delta. I can do it with lines. It only works with lines. But let's pretend we don't see it. So, well, you guys agree these things are like terms? They both have m's. How do you subtract things with like terms? Okay, let me let's make sure. You guys agree this is m times x minus 2? Okay, is less than epsilon. This is less than epsilon. Okay. Now what do you do? Yeah, get rid of absolute value. Negative 0.03 is less than m times x minus 2. I don't know if I even had to do that, to be honest. Is less than 0.03. There's a couple different ways. Nah, this is good enough. Now what? Divided by m, yeah? Because remember, I'm solving for x, right? And the outermost piece is m. You guys agree? So this is negative 0.03 all over m is less than x minus 2, which is less than 0.03 divided by m, right? Plus 2. Negative 0.03 all over m plus 2 is than x less than 0.03 over m plus 2. That's your interval, right? So remember, we have our interval right here. If you want to draw it as a picture, this is negative 0.03 over m plus 2. And this over here is going to be 0.03 over m plus 2. And what's going to be right in the middle? 2. See, 2 is going to be right in the middle, right? Because this is going to be your c value, isn't it? So remember, when you find these things represent your endpoints, right? Okay. So how do I find this? How do I find that distance? How do I find that distance? Yeah, take the absolute value. So remember, it's the absolute value of x minus c, right? Where c is 2. And I'm just going to plug this into here, and then I'm going to do the exact same thing, x minus 2, and I'm going to plug this thing in here. So this is going to be the absolute value of negative 0.03 over m plus 2 minus 2. So the 2's cancel, so this is the absolute value of negative 0.03 over m. M is positive, so this is a negative number, right? Oh, my bad. Sorry. So remember, in order to find that distance, you take the absolute value of x minus c, right? So first, this piece is going to go here. Same thing here, the absolute value of x minus 2. This piece is going to go into the x value, right? So for the left one, plugging that in for x, right? Plugging that in for x. What happens to the 2's? Good. This is a negative number because m is positive. That's what they said up here. They said m was positive. So what's the absolute value of a negative number? Yeah, so this is going to be 0.03 over m. Or, you know the other one, plugging that in, 0.03 over m plus 2, because that's what this piece is, right? And then I still have to subtract 2. So the 2's cancel, so the absolute 0.03 over m. This is a positive number, so the absolute value just drops. What one's smaller? Yeah, they're the same, because remember, this is a line, right? If it's linear, you'll get the same distance both times. So delta is going to be equal to 0.03 all over it. Now to kind of show you something here, we could have done it right here. You guys notice how m is positive? Since m is positive, I can factor it out of the absolute value and I get this thing, right? And then if I isolate that absolute value, if I isolate this thing, if I get something that looks like this, the absolute value of x minus 2 is less than something, that thing needs to be your delta, right? So if I divide by m, you're going to get that 0.03 over m, so that thing's your delta, isn't it? It only works for linears. You can pull stuff out like that, okay? So I know it's a lot quicker than what we just did, but this method here works for everything, even like radicals and squares and stuff like that. All right, 33. You guys, make sure you can repeat this. I've just done half your homework for you. Be sure you can go back and do it yourself. So 33 says f of x is equal to x squared over 4 all over x minus 2. And this says c is equal to 2 and epsilon is equal to 0.05. What did they not give you this time? Okay, can I find out? Yeah, the limit as x approaches 2 of x squared minus 4 over x minus 2, right? This is the limit as x approaches c of f of x is equal to L. That's what we're trying to do here. So when I find this limit, how do you do this limit? What do you got to do? Simplify. So I'm going to simplify through factoring. So the top is the difference of squares. That x minus 2 goes away, so this is going to be equal to the limit as x approaches 2 of just x plus 2. Now I couldn't plug in 2 into the original expression because the bottom would be 0, right? You get 0 over 0. Again, never on a test, when I ask you guys to find the limit, if you write 0 over 0, guess how many points you're going to get? 0, okay? So be sure that you guys simplify first. So if you wrote 0 over 0, it means you didn't simplify. Is that clear? It's supposed to be funny. It just sounds mean. I'm sorry. Okay, so now I can plug in 2, right? So when you plug in 2, what do you get? Yeah, this is 2 plus 2, so this is equal to 4. So my limit's equal to 4. So now we can finish this off. So 0 is less than the absolute value of x minus c, which is less than delta, implies that the absolute value of f of x and L is less than epsilon. And then plug in all those values in. So 0 is less than the absolute value of x minus c, which is 2, less than delta, which I don't know, that's what we're trying to find. And then I'm going to have the absolute value of f of x, which is x squared over 4 all over x minus 2 minus L, which is not 2 but 4, right? Is less than that epsilon, which is 0.05. We know that we start here, right? This is going to be our starting spot. How do you simplify this expression? Like, I kind of gave it away. How do you do this? How do you simplify this thing here?
Isn't that first part equal to x plus 2?
Yeah, well, remember that it's not directly equal, but you're really close, right? Because remember, the limit doesn't care about the value at 2, right? So what I know is I know these two expressions are identical as long as x is not equal to 2, right? And since we're taking the limit, x will not be 2, it'll just be very close to 2, right? So it means I can replace this with the limit, right? So that means this piece right here is just going to become x plus 2. So the absolute value, that's going to become x plus 2, and I still have minus 4 is less than 0.05. So remember that that expression and that expression are the same everywhere x is not equal to 2. Simplify that absolute value, x minus 2 is less than 0.05. Which is actually, we're technically done. You guys see that we have the absolute value of x minus 2? We have what looks just like that, doesn't it? So this is your delta, just to let you know. Because this thing and this thing are the same. But let's pretend we don't see that. So dropping absolute values, negative 0.05, is less than x minus 2, which is less than 0.05. Adding 2, I'm going to have 1.95 is less than x, which is less than 2.05, and I can see that c equals 2 lives in here. So I know I have 1.95, I have 2.05, and I know that 2 lives right in the middle of it. So when I find my delta, delta is either going to be equal to the absolute value of 1.95 minus 2, or delta is going to be equal to the absolute value of 2.05 minus 2. And we can see that in both cases, delta is going to be equal to 0.5, right? So that's your answer. All right, I'm out of time. So, dang it, I'll do the last problem. I'm sorry, I didn't do one in class, so I need to make sure you guys see it. Okay, so 37 asks us to prove the limit as x approaches. I'm doing 38. Tell you what, I'll do 38. You guys can do 37. Prove the limit as x approaches 3 of 3x minus 7 is equal to 2. So in order to prove this limit, what I have to do is the exact same thing that we did before. The absolute value of x minus c, which is 3, right, because that's what this is less than delta, implies that f of x, which is 3x minus 7, is less, the difference between that function and this limit is less than epsilon. So remember, this is just your c value, this is your f of x, and this is your L, right? That's where all that came from. So what I'm going to do is I'm going to start here. So the absolute value of 3x minus 7 minus 2 is less than epsilon. When I simplify this, the absolute value of 3x minus 9 is less than epsilon. What I'm trying to do is I'm trying to find this expression of the absolute value of x minus 3. Is there anything I can factor out of that to get to the absolute value of x minus 3? Yeah, so I factor 3 out. Absolute value of x minus 3 is less than epsilon. So if I isolate that absolute value of x minus 3, I'm going to get less than epsilon over 2. So since this expression and this expression are the same, right? You guys agree they're the same? The left-hand side is the same? So if the left hand is the same, then the right hand has to be the same, right? So what's delta? Epsilon over 2. Over 3, you're right. Epsilon over 3. So let's make sure what this means. Just, there's a line, whatever, hold there. The idea of a limit says, as this shrinks about my c, yeah, the idea of a limit says, as this shrinks about that c, then this has to shrink around that L. You guys agree? That's the idea, that as it shrinks horizontally, it has to shrink vertically, right? So this is epsilon over 3, this is epsilon over 3. You guys agree? You guys agree if this thing gets smaller? If epsilon over 3 gets really small, what's going to happen to delta? It's going to get really small, right? It's going to be 1/3 smaller. You guys agree? So as this gets small, then this gets small. So that's the proof of it. If you can get a function of delta, if you can have delta as a function of epsilon, then you can prove that as this gets small, then this will get small, so the limit exists. All right.